2.0, how containers, microservices, and open source software are redefining cloud computing. I'm Mark Hinkle. I work at the Linux Foundation. I have for about 2 weeks now, but my background is, before that I worked for the last 5 years in cloud computing. So I worked for a company called Cloud.com. Cloud.com was bought by Citrix. We had a product called Apache CloudStack. When I was at Citrix, I was on the board of Zen Project, the Zen hypervisor, and our product was Zen Server, which we open sourced, and spent a lot of time working with Apache, the Open Daylight, which is a SDN controller that is a collaborative project Linux Foundation, and that's where I am today. So while I said VP of Marketing, I'm a committer in Apache CloudStack and have spent a lot of time with these technologies. I'm also sort of opinionated, so I will try and give you a good lay of the land and let you make your own choices, but keep in mind these slides are stuff that I've worked on, so I sort of have a propensity towards these technologies. I did put these slides up on SlideShare if you find them interesting and want to get any of the links or anything. I usually try and put speakers notes in my talks with links to stuff I talk about so you can go do your own research and find that stuff. So I've been doing cloud talks for the last 5 years, and during that time I've given the same talk probably every month for 5 years, but it's updated. So it's sort of like that evolution of dance video. You sort of start out slow, and I am not going to recreate that video because nobody wants to see that, but we'll sort of talk about the evolution of cloud. So back when I used to give these talks, this is the diagram I'd always start with. I'd be like, we have this thing, it's called the cloud, and we have this public cloud, and then that's cloud infrastructure hosted in other people's hardware. And then I have the private cloud, and that's hosted on our own hardware and then in our own data centers. And then we have this hybrid cloud, which transverses the firewall, and we'd spend the first 15 minutes talking about that. That's not really the case anymore. I mean, I don't think anybody, most people get that now. How many people here use Amazon EC2? Okay, or Google Compute, Azure. All right, yeah. How many people would identify as being a system administrator or developer? I went through the Balmer developers either, but that's good. How about just IT support or generalist kind of people? Networking people? That's cool. All right. That sort of helps me in the way I talk about things. So this is what I talked about 5 years ago. Everybody was cloud. And this is sort of what's happened over those years. And as I am getting old with my progressive lenses, I hopefully will be able to read the tiny little print. But the thing I think is interesting is this whole cloud thing started way before we started talking about cloud. And I really think that's, in the mid-90s, they had a movement around service-oriented architecture, and SOA was a big buzzword. And then later on, the service-oriented architecture movement sort of faded a little bit, but we're going to talk about that a little later. The thing that really kicked this off was this whole cloud rage was Amazon and their launch of EC2 back in 2006. So that was really sort of the landmark moment when they started to host compute infrastructure, and it was in a very different way than what we did for virtual hosting because it was elastic. And then all of a sudden 2010 came around and we started seeing these knockoffs of Amazon from open source. OpenStack was launched, Eucalyptus, CloudStack was launched as open source, and we started seeing these open source platforms, so like Linux to the Solaris era. Then 2013, a company called .cloud was a platform as a service provider, and .cloud relaunched themselves as Docker. And now every time you go to a conference, we hear everybody going Docker, 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 Docker. How many people here use containers, Docker? Cool. Which I think is cool. I'm not being pejorative. I just think that people are gaga over containers right now for many reasons. Then 2014, we started seeing the rise of PaaS, so Cloud Foundry, and actually Pivotal launched that as a foundation under Linux Foundation, and put it in a governance model that allows everybody to participate equally. And then Google did the same thing with Kubernetes and did the Cloud Native Foundation. Now I'll point out I've been given this slide for like at least 6 months, and now I'm at the Linux Foundation, so I wasn't really realizing I was hawking all their collaborative projects, but sort of makes sense why I ended up there. So we're in what I call the era of cloud abundance. We got cloud choices, we got competitively priced, we have PaaS that's hosted, we have PaaS we can run in our data centers, we have containers, we got microservices, we got all this stuff. And what I'm trying to do is take us on this little journey from what we have, how it's evolved, and where we're going. So in this era of cloud abundance, you can see this is some like analyst chart, but basically the amount of cloud that people buy every year is increasing by 24%. And you can sort of see a breakdown that platform as a service has one of the highest growth rates, and we're going to talk about that in a little while. But before we do that, I want to talk about what we did in the past, because if you didn't learn from history, you're doomed to repeat it. So let's talk about Cloud 1.0. So this is, Amazon is launched, Google is launched, and we have all these, what I call copycat clouds, of which I was one of them. So copycat clouds were the idea that we wanted to bring Amazon into our own data center. So this is actually, I was involved in the first press release, is the cloud stack was Amazon-style clouds. Then you had Eucalyptus. Eucalyptus was bought by HP, but it was one of the first open source clouds to launch. And their claim to fame was they wanted to keep as close to 100% fidelity to the Amazon API so that all your tools would work. And there's another one back in 2012 where HP was talking about their HP Cloud Compute and undercutting Amazon. That was an OpenStack-based cloud, I believe. But is anybody familiar with the Netflix open source program? It's a pretty interesting program. It's a bunch of tooling from Netflix operations that they use to run stuff in the cloud, and they scale out their business on Amazon, which I find is interesting because they have some hyper elite operations folks. They really, have that Devops culture. They're at the forefront of operations, and they use Amazon. And the way that they scale out is they build on top of Amazon, and when they go into new geographies, it's dependent on whether Amazon has a good enough footprint for them to deliver their services there. So the guy who used to be the architect for Netflix Cloud was a guy called Adrienne Cockcroft. Has anybody seen him speak? Or he speaks at a lot of cloud conferences, a lot of open source conferences, and now he's a technical advisor at Battery Ventures. But he's a really smart guy, and he said that people would ask, well, why aren't you doing it on Google and Amazon? And he said, well, using multiple clouds is like Roman riding. So that's Roman riding, where you stand on one horse. So having multiple clouds and trying to run your operations across the cloud is really, really difficult. It's really hard to balance, and eventually something falls down. So, he said, we decided to go with Amazon, and it made things a lot easier. And he had looked at things like CloudStack and Eucalyptus, but their choice was to scale out everything they could on Amazon because they didn't want to have this Roman riding problem. Also in this Cloud 1.0, people were very, very particular about the silos of how they define cloud. So they're like, is it a public cloud? Is it a private cloud? Is it a hybrid cloud? And what that meant. So that sort of, if you read Information Week or InfoWorld or one of the trades every week, they would have like private cloud roundup and public cloud roundup. And that's really, I don't think, a good thing, and we're sort of getting past that in what I call the sort of Cloud 1.5 era. And this is what happens in the Cloud 1.5 era. There's lots of people like Twitters and Facebooks and Netflix and PayPals that are really interested in cloud, and they're building the infrastructure, and those people are adopting it, but people that were sort of enterprise operations were not really getting on the bus as quickly as them. And then all of a sudden they're like, hey, it's not just for the .com people, it's for everybody, and we're really missing out. So all of a sudden, probably like 2010, everybody's scrambling for their cloud strategy. Or, 2010, maybe 2013, I think is where it's started to peak and take off. So enterprise IT started saying, hey, I got to play catch up here. And this graph is from a guy from Simon Wardley is a analyst from CSC Corporation, a blogger, really smart, really opinionated guy, which we used to be the vice president of cloud at Canonical before he took that gig. Now the difference between cloud, and like in Cloud 1.0 area, a lot of people use the tool called RightScale. Anybody here use RightScale in the past? And I mean, RightScale took off because it was one of the few tools that you could use to manage cloud workloads effectively, and it was a hosted tool. Now in this 1.5 era, in the last few years, we just see a ton of new tooling come out that is really interesting. So things like in configuration management, we had Puppet, but now you have Chef and Puppet. You have Ansible and SaltStack that are sort of helping to solve those same kind of automation and configuration problems. You've got anybody here know HashiCorp? They do like Vault and Vagrant and a million other things that are really cool and awesome. You have Docker out there now. You have a ton of ManageIQ, which is a cloud monitoring that's a Red Hat sponsored project, and you can go on and on. So we're in this era where the tools that we have today are becoming as useful as the tools that people used to spend millions and millions of dollars for back in the 90s. So back in the days of the Tivoli and the BMC, and I mean, which are still around, but not in the as abundant as we'd like, or not as cheap as we would like, I should say. And the other thing that I think is the catalyst for this Cloud 2.0 or 1.5 era is sort of this change in culture. So how many people here did anybody go to Devops Day this week? Okay. Anybody here, how many people here have heard the word DevOps before? Okay. I just like to make sure because, so just this cultural change about, that sort of reverses the conventional thinking on operations, which my wife works at a very large conservative pharma company in IT project management, and they're of the, they do releases once a month, and they plan, and they're going through ITIL, and they have processes over processes, and they have silos of people in development and operations, and she's the person that bridges operations and development. Like, they don't really talk together. It's sort of these old school kind of ways to manage IT. Now do you guys know who the guy in the middle is? His name is Patrick Dubois. Patrick Dubois is the guy who started the DevOps movement, and is a real low-key guy who lives outside of Brussels and Belgium, and sort of started the movement probably hasn't made a dime off of DevOps, but it's one of the biggest transformative movements in IT and as long as I've been around. Anybody here read the Phoenix Project? So Gene Kim, anybody who ever used Tripwire, Gene Kim was the guy who started Tripwire, and now he is a sort of evangelist around IT trends and sort of has the mission to help improve the lives of people in IT is his stated goal. And he wrote this book, The Phoenix Project, which is actually a story that sort of encapsulates the ideas behind DevOps in a real life, fictional kind of situation. And then you have people that are setting the model, and I mentioned earlier Netflix. So you have this change in culture, you've got tools, and you've got an abundance of cloud stuff. Then you have this one final thing, which I call the cloud industry shakeout. So if we talked about public cloud, these days the way I look at it is there's only 3 vendors in what is truly the generic public cloud, and I'd say that's Amazon, Google, and Microsoft. And what I mean by that public cloud is they have a global footprint at massive scale, and they move really fast. Then you have this other sort of tier, and actually since I've recently seen that CenturyLink was talking about selling off their data center assets, so I'm not sure if I would how I would qualify that anymore, but the idea is that the people that own the pipes, so the telecom bandwidth providers, the data pipes, the level 3s, people like that, are sort of offer these managed services, because not only do they have the cloud, but they have the end-to-end network, and so a lot of people are looking at, they can get end-to-end security and SLA from not only their compute and storage, but also the pipes to carry it back and forth. They are at a premium over what you'd pay at Amazon. Amazon has tons and tons of services and a huge ecosystem. These managed service providers offer something above and beyond. They're a premium service. And finally, I have what I call the SP and the SI cloud. So SoftLayer is IBM. I think that's the best example, and they have system integrator capabilities, enterprise trust, so they already probably are selling you things, your mainframes, your software, your Java platforms, things like that. I have HP on there, but it seems like every time I check out HP, it's not clear whether they're all in on their own cloud or if they're going to, be an arms dealer or to everyone. So that's where I think SoftLayer is one of a large example of these SPSI clouds. There's people in Canada that I think do a real good job called Cloud.ca. They have a public cloud, but they have a really great services shop integration. That kind of cloud I think is interesting, and they'll build it for you. And then finally, there's another one in the Netherlands I really like. Now the reason I like them is because they use CloudStack, but they're Schuberg Phils, and they're in Amsterdam, and they do a lot of custom-built clouds and run clouds for their customers. Their services offering, and they lease their lines. I think that's interesting. So those things are the shakeout, and then this final thing that is like the miracle that's saving cloud is containers. And I'm being a little facetious. I think it's really interesting. I think it's important technology, but the container availability is now helping with the one problem that made cloud siloed was portability of workloads. Containers make it really easy to move a workload from cloud to cloud, from your data center, from development, from wherever you want, and run it somewhere else. That's why I think people we've been calling it the flux capacitor for cloud computing. It's what makes cloud computing really possible. And all these things I list here are benefits. How many people do continuous deployment from development to production in containers? Anyone here? Cool. How many people just use it for production and of open source software? Anybody have proprietary products that are running in containers? Okay, cool. So as we finish this 1.5 era, I think the thing that's interesting is we have all these tools. We have this movement of open compute. If you went by the Facebook booth this week, they had their open compute thing out, so they're opening up the hardware, which I think is interesting. It's probably not affecting us now, but it's going to affect us a lot later on. I think it's going to drive a lot of standardization in the hardware we use, because variance is the thing that makes things difficult for a lot of the things we want to do. So open compute with a more standardized footprint for your hardware. On our compute layer, this is the virtualization layer. We add things like KVM and Zen. We've had VMware, but now containers is virtualizing our compute layer. We have distributed storage from Ceph and Gluster. How many people here use Ceph? Okay, wow. How many people use OpenStack Swift? Or OpenStack Storage is the correct term. Interesting. How many people use distributed storage from EMC or NetApp? Okay. Interesting. Then we have networking. I listed in Open Daylight as sort of this SDN layer around networking. I don't know that it's dominant, but it's certainly one of the leading controllers for virtualizing the network. So, and I think that's key, because as you have things moving around in your cloud, you want to make sure that if you virtualize your compute and your storage, if the network isn't virtualized and you can't program it the way you can your other infrastructure, it's going to be a limiting factor. Above that, we have OpenStack. And how many people here use OpenStack? Okay. Anybody here use, Joint is now SmartOS. Anybody use SmartOS? Well, Joint is a company, but SmartOS is the open source. Anybody here use Apache Cloud Stack? One guy. That's good. And then you have in the cloud, public cloud, you have EC2, Azure, Google. And then on top of that, you sort of have this abstraction layer on top of the infrastructure from Docker's containers. You have Mesos. Any you guys know what Apache Mesos is? Okay. And Kubernetes. So Kubernetes is a scheduler that Google wrote to help manage containers. And then you have this platform as a service. Now, honestly, I've seen Cloud Foundry and OpenShift and GigaSpaces all in production, but I think one of the ones that has the most momentum behind lately is Cloud Foundry. How many people here use a platform as a service layer from one of those three? Bueller? All right, okay, interesting. So all this stuff sort of has evolved, and now it's present day, and this is what I call Cloud 2.0. That's where the magic happens. So Cloud 2.0 is that magical place where everything works and our infrastructure is elastic, and we have almost zero downtime, and we do 20 releases a day, and it doesn't break stuff, and our customers love us, or end users love us, and that's where we're at today. And here's what I see coming in Cloud 2.0 is, well, that slide just shouldn't be there. So first off, we have all the infrastructure is open source, is available, and there's a layer, every bit of that layer is available in open source. And I think that it's really interesting from an open source angle that I look at it this way. There's a lot of competition between companies and whose products are better. The reason I like open source is it isn't a zero-sum game. This is a quote that I use all the time from Allison Randall, who, when she was the program chair at O'Reilly, said it, and I really thought it was interesting, is in the old days, people like IBM and BMC and Computer Associates all were very, very competitive for this infrastructure layer, and they all were developing things that were overlapping. Today, we see a lot of, in open source, you see people like HP and IBM collaborating on the Linux kernel, and you see them collaborating on infrastructure stacks and things like OpenStack, and they're not wasting their resources on things that have low value. They're really driving through a lot of innovation, a lot faster speed than before, and I don't think that would be possible without open source. So earlier I had talked about Simon Wardley and his sort of theories, and his ideas are basically you only develop what doesn't that's so badly written, I had a little hangover this morning. Develop what doesn't exist to meet your needs, leverage the growing base of high quality software like Linux and OpenStack and Cloud Foundry and virtualization like KVM and Zen, and then commoditize things like Linux. So everybody is sharing, development of Linux across the industry. A lot of people are sharing development of OpenStack. You leverage what's there in OpenStack, but you also commoditize the stuff that isn't differentiating, like scheduling workloads. That in itself is not really interesting, but the logic on top of how you schedule the workloads are pretty interesting. So earlier I was talking about that I had that little timeline, and we're talking about back in the 90s there's this thing called SOA. They talked about componentization and a design pattern which is where individual components do a single thing via the web and are loosely coupled. That is very much what sounds like microservices today. How many people have heard the word microservices over and over and over again? So the thing that's interesting, and I mentioned earlier about Netflix, is the way that they create their infrastructures based on microservices. So they have a microservice that does one thing, and maybe that one thing is, I don't know, encoding a movie, and it only encodes movies, and you can call that to encode movies for redisplay across their network. And the way that they deploy this microservice is they deploy it to do this one thing only, and if they make improvements to the service, they don't redeploy the service, they deploy microservice 2.0. And the microservice 2.0 is backwards compatible with 1.0, but it has all the improvements. So the application developers actually consume those services as they're ready, not affecting everything in production. So if North America is using this encoding service and they're ready to go to 2.0, but South America operations region isn't, they can actually just choose not to consume that till they're ready. And then you can leave those microservices in production forever or until they're no longer used, and you can pare it down. So that sort of loosely coupled network infrastructure has actually been talked about since the mid-90s, but actually you start seeing it in practice now in the cloud era. And part of it's because we're in this area of cloud abundance I was talking about earlier, where there's things like that. So we talked about containers earlier. Now, did anybody see the Docker news today? What kind of company did Docker buy? Unikernels. So now we're going to go to conferences and they're not going to say Docker, Docker, Docker. They're going to say unikernels, unikernels, unikernels. And actually, I think they're talking about unikernel, the Docker guys next door talking about unikernels now. Now, earlier on, I was talking about what I've done in my past, and one of the things, I was on the board of the Zen project and worked on that for the last 3 or 4 years. And one of the things that came out of the Zen project was this thing called Mirage OS, and Mirage OS is a I don't know what the right term of art is, a unikernel runtime, and basically what it is it's a sort of anemic operating system if you don't like it, or a fast and lean operating system if you do like what they're doing. And what they're doing is they're packaging configuration files, the binary, and just the necessary libraries for them to actually run this image on, and you can run it within, I know about Mirage because it was a Zen project. You can still use the hypervisor to run these things. You could also probably run them within containers and make your containers lightweight. So that's sort of, I'm not sure how that plays out exactly in the Docker container space, but I think it's an interesting technology that is really going to change, is really going to be a part of this Cloud 2.0 era. Now, all this sounds well and good until you start thinking about what's the downside to all this. And somebody asked about this. Anybody here read the News Stack? It's a news site. It talks about cloud. It's pretty avant-garde. The guy used to write for GigaOM, but he asked Mitchell Hashimoto, HashiCorp, what he thinks the #1 problem in cloud is, and that's service proliferation. So now, we're in this area of abundance, but we also have service proliferation, especially as we start to consume microservices. And now you're going to have all these microservices. So, it's great to have abundance. It's hard to track abundance. Because that's what I call the zombie problem. So what's the worst thing you can do in the zombie movie? The guy who always dies runs into a house that has a lot of windows and doors, and you have a bigger attack place. So now we have all these microservices running, and you have all the windows and doors, and the guy in The Walking Dead that runs into the house and bolts the door and leaves the back door, and you see all the zombies run in. It's because there's lots and lots of openings. That's the downside of this era. So today, as I said earlier in that shakeout, I think that the public cloud is this. This is what we look at. And I think those prices, I haven't seen a big Amazon price drop lately, but it seemed like for the last 5 years, just when you think computing can't get any cheaper, it gets cheaper. Security used to be the big criticism of these guys. I think they're probably getting more secure. Now we have things like Docker and Amazon supporting Docker and maybe unikernels at some point. The portability problems across cloud is changed. So you want cloud computing to be like electricity. Like the initial terminology for cloud computing the IBM used to champion was utility computing. And you want to be able to plug in your workload just like you can plug in your laptop to outlets and have them be standard. And you're also going to see, I think, from these guys, a proliferation of microservices. So Amazon is masterful at coming up with supporting services for your EC2 instance. So they have monitoring services. They have a suite of continuous integration tools. They've got, NoSQL database services and Java container services and all these things to add on. I think you're going to see microservices that are going to be, more data streams and other kinds of things we haven't seen in the past. Then in the private cloud, you're going to see what I call in the private cloud, I think is what really is the minimum viable cloud. Because if you try, in the early days, I think where we went wrong is we were just trying to keep up with Amazon. Well, Amazon has one architecture target, and when they make changes, they control all the variables. If you're a software developer trying to develop software to run on all these different infrastructures and have all these different variables, it's very, very difficult. So I think what's evolved is with OpenStack, which OpenStack I feel like is an ecosystem for you to consume the parts you need to make the minimum viable cloud, which a lot of times I think will be done by vendors like Mirantis or Red Hat or numerous other people in that industry. My personal the reason I've always been such a big fan of Apache Cloud Stack was simply because it always has been a minimum viable cloud. It did, one thing really well, and it's scheduled workloads for cloud computing on your own hardware. I mean, it does not have massive number of sub-projects and identity management. It used standard protocols for all that, whereas things like OpenStack has a project for each one with a lot of support, so they're legit too. And then SmartOS comes to you from the people that did Joyent, and the thing that's interesting about SmartOS is it comes from the Solaris root, so I think it's the Luminos, is that the open source Solaris kernel now? Then Joyent is really a pretty good cloud hoster. They're really smart. They had the idea of containers and used them for quite some time in just a little bit different format than what we're used to, sort of leveraging the Solaris zones model. The foil to that is Linux sort of copied that idea with LXC and the container model, but that wasn't exactly an original idea. Just a very good implementation on an operating system that has wide appeal. Then we have what I call this Public Cloud Plus, and probably the one that I think is most successful is not a wide use cloud, and I think that's Salesforce. So they bought a company way back called Heroku, and the brilliance of that was Heroku was a platform as a service, so you can write your applications for Salesforce and then hook them into your CRM and host them. It's pretty brilliant. But they have they're not just virtualized infrastructure and elasticity. They've got high levels of service. They have tooling. They have continuous integration. They have a lot of things that make their public cloud plus. And I don't even mean that to be more features as much as, I mean it to be more features, not better features, or more specific ones, I should say. So in the early days, we had those silos, and I think what's happened now is those silos are sort of gone. I think the Cloud 2.0 cloud there's just cloud, and it may be in your own data center, and it may be in someone else's data center, but you're weaving together all these different things into a single fabric, which is what cloud is. We're getting better at bridging between our data center and their data center. There's services that are hosted with microservices. I think we'll start consuming things across different providers and weaving it into fabric from our data center and Amazon or Google. So that's sort of how I think that this all evolves. I had 40 minutes worth of content, and because I had written down this was 45, so I have plenty of time for Q&A. If there's stuff like, right now I spend a lot of my days with, this week I spent my days with Cloud Foundry one day, talked to the guys that are running the Cloud Native and the Container Initiative, Linux Foundation. I spend a lot of time with the Apache mailing list for Cloud Stack. And so if you have a question of what do you think, or where can you point me to get more information of what you're trying to do? How many people here are considering building their own cloud in their own data center? How many people here are just trying to figure out what all this cloud hoopla is all about and how it all fits together? Yeah, I think, when I got into IT, it was right in '95, and the thing that was the biggest transformation for me is I worked in an internet service company, and everything ran on Solaris. Now, if you know anything about the internet service company, they make very, very little money per customer. It's like razor thin margins. So, and the Solaris hardware at the time was really, really expensive. And so I think Pentium, just the Pentium processor came out, the first post 486 processor came out, and so all these machines were getting decommissioned, and they were like DX2 66 megahertz machines, and these Solaris boxes were really expensive. They're sort of these pizza box things, and they're real funky looking, and every couple weeks you get CDs in the mail with your updates, and you go around, press the CD in, and it was that guy's there like shaking his head like it was pure hell. Like you were not doing pixie booting and updating stuff. It was manual. So the thing that was transformative was these DX2 machines that we had. We could put this operating system on that we could get for free, that Linux, and it had zero incremental cost added to these boxes. Other than time, which in those days, the thing that was the limiting factor was driver support a lot of time, like for storage arrays and things like that. But that was that sort of era of abundance in the operating system, and that just changed the way that IT growth just went gangbusters and started the .com. I feel like all these cloud services, cloud tools are like that next wave of things that are just going to accelerate how effective we use IT.
What do you know about cloud orchestration tools that specifically for Docker, for orchestrating, managing, monitoring? I've seen a few, but none of them seem to be really.
So the question was, what do I know about cloud orchestration tools for Docker? I know that there's a huge need for that, and so I mentioned RightScale before. So RightScale back in the early cloud days was going gangbusters because it was a good orchestration tool for infrastructure in the cloud. Right now, I think that's sort of the next. So Docker has some of these tools. I think Kubernetes was a huge thing, and I think the Kubernetes management is sort of going to be the next set of tools. And I'm going to give a shout out to an open source project called Skipbox. And Skipbox is written by a guy named Sebastian Gozgan, who is in Geneva, Switzerland, who's pretty darn smart. He's the VP of Apache Cloud Stack. He used to work for me. Because he's the smartest guy I know on that, and he decided what he wanted to do for his own personal project was write this thing called Skipbox. So it's on GitHub. I would definitely go check it out. Tweet to him. He would love to hear what you think. But the idea is, I think that you use containers and then you use Kubernetes, but there's still some orchestration tools to maximize the way. Kubernetes is, if you guys don't know, it came out of Google. So everything that you touch for Google is part of this thing called the Borg, and they just add their workloads into this great big mesh, just like the Borg in Star Trek. And so that software that runs the Borg, Kubernetes, they spun out as Kubernetes because they want workloads to be easy to move across from, your infrastructure to their infrastructure, and, make your world better. But Skipbox would be a place I would look. But I think there's going to be a lot of other stuff. I'm rooting for Sebastian to. So Rancher, that's coincidentally, I always forget about Rancher. Rancher was started by two guys, Sheng Liang and Shannon Williams, who are co-founders of Cloud.com and worked with me at Citrix. So I do know about Rancher and Rancher OS. And actually, they're smart. Sheng was the guy who wrote the Java virtual machine for James Gosling's team at Sun. He's crazy smart. What I'm trying to figure out from the vendor-led projects, and they're a venture-backed company, and have a lot of one of the best engineering teams I've ever worked with. Two of their architects are just out of this world, and a lot of the engineers are amazingly smart. Whether or not that layer of tools can be commercialized or becomes part of the open source ecosystem is what I can't decide, because Google, I feel like, wants that to be a very democratic layer that everybody participates in, and there's not a lot of vendors there. So I think Rancher has some value, and Skipbox has some value, but I think it has better shot at the open source tools till we figure out like what the Kubernetes management layer looks like, or orchestration layer looks like.
There's another one called DCHQ.
She just said there's another one called DCHQ. I haven't.
It's not open source on
Yeah. So that's my, like, I'm fine with proprietary software. I'd love for free and open source software, but the thing is, if you go back to the strategy, is develop the stuff that doesn't exist and commoditize what has very little value. Over time, I wonder how much those orchestration tools are going to be commoditized by everyone, because everybody, or not everybody, but you see more and more participation in the end user in the creation of this software and infrastructure tools. And I think that's why I'm like, Rancher OS may become, well, Rancher is open, so has an open source component to it. So that what they're doing there might be commoditized, and maybe someday Rancher is in the business of like reporting on what all the stuff's going on in your dashboard business, for example, or something like that. But it's moving so fast, and plus Docker themselves and CoreOS, like CoreOS. And anybody here know CoreOS? So they're an operating system that uses systemd and schedules container workloads very, very effectively. I probably didn't do them justice by that, but they also, I think, are going to be heavily involved in creating management for Kubernetes. I think they do a lot of services around that. So, yeah, it's sort of the early days of, and it's sort of tough because if you start investing your time in a tool, you want it to be around for the next couple years. So it's great to be on the leading edge of technology. It stinks because you're the canary in the coal mine for everybody else to figure out how to get it done. Yeah, but anyhow, I do think though that the way that they talked about cloud for 20 years ago, when the SOA people, if you see a guy or a gal who worked at IBM who used to talk about SOA, and they show up at a cloud thing, they're just like nodding their head like, yeah, this is what we talked about, but they were selling those tooling and infrastructure via IBM, and not just them, but other companies. And now there's this abundant amount of infrastructure and inexpensive access to public cloud, which is really driving a lot of cool things. So that is pretty much all I had. My contact information is there, which apparently is really, really tiny because I changed the font, but I am I'm MR Hinkle on Twitter. If you Google my name, I am usually the first hit on Google for that. My blog is Socialized Software. I'm happy to chat with you or direct you to someone much smarter than me on cloud. But I hope this was a good overview of how it all fits together, what you should be considering, and there's tons of good talks on the people, like the tools that I mentioned. All those HashiCorp tools are really interesting. One that I think is pretty cool that's fairly new is Vault, which allows you to manage your public and private keys across clouds, which is sort of a pain in the butt. Like Google makes it easy for you to do it in their cloud, but or not Google, Amazon, and Google does too to some degree, but his tools that work across all clouds. Just tons of good stuff. The Ansible, how many people here use Ansible? So I think it's interesting. So this is my little sidebar on tools. Like the thing that really has driven operational efficiency and automation, in my opinion, is this whole cottage industry around configuration management. So it started with CF Engine, and CF Engine is this management orchestration tool to manage configuration of infrastructure, started by a guy who's really, really, really smart, and his name's Mark Burgess. And he just wrote a book. If you'd like to geek out on like operational theory and why things end up working well, it's worth its read. And I wish I could remember the name of it, but he started this sort of movement, and then this guy came along, Luke Knies, and Luke Knies liked what he did, but it didn't quite work for him, and he's, anybody use Puppet? So he's the guy who wrote Puppet, and so he took it a step further and came up with some things that are interesting, the idea of inheritance and some other activities. He really got a big following in the operations community. And then came Chef. Anybody here use Chef? I feel like Chef's pretty popular in the cloud world. And that was done by a guy named Adam Jacobs, who liked what Luke did, but he had a ticket. Actually, there might not be a Chef. He had a ticket, and Luke's like, well, I'm not going to do that ticket. He's like, okay, I'll write my own configuration management thing. So he did, which is good, because I think diversity is good. And then all along the way there was this guy at Red Hat. His name was Michael DeHaan. And Michael DeHaan wrote something called Funk. Anybody here know Funk? He wrote the thing that automates Kickstart too, and it's used all over the place. You pixie boot to this management thing. He wrote all this management stuff at Red Hat that sort of was the glue behind it, including a lot of stuff for Red Hat, for Puppet. And Cobbler that's what it is, Cobbler is. Anybody here use Cobbler? Yeah. So he wrote Cobbler, and all along the time, this way, he was thinking, well, you know, I like what the Puppet guys that they're doing. He integrated Cobbler and Puppet, and he wrote this thing called Funk. He's like, it sort of did what I wanted it to, but he baked these ideas and wrote this thing called Ansible. So, ironically, he wrote this, moved to Durham, Red Hat's in Raleigh, North Carolina, where I live, and moved up the road for a couple years, and had a couple jobs, but wrote this thing called Ansible, which Red Hat recently bought for $100 million, when the guy used to work in the back room probably give him a raise and some better coffee, and he would have been happy. But I think that his difference was where Cobbler and SaltStack falls into that same bucket too, is he built this thing with the idea that he just wanted to execute things, and this execution environment is what was valuable. And then by virtue of the fact that it was modular and you could execute scripts, you could execute these configuration scripts, which I think might be called playbooks or something like that, and they're written in YAML. And basically, so now this is sort of the way that a lot of people are doing configuration management. But at the end of the day, these tools are what's making you able to automate and keep up with cloud infrastructure, because now you can spin up, hundreds of instances in minutes, where before, like when they used to let me touch servers, which is not a good idea anymore, like you call somebody on the telephone, like there was no online ordering for Dell, and they would send you these servers on a pallet, and they'd come to the shipping dock, and you take it out of the pallet, and it was like the slowest server with like 16 megs of RAM, and you'd put it in the rack, and you'd bust your knuckles, and then you'd have to wire it in, and then you'd have to go back, and you'd have to open up your firewalls and your checkpoint software, and blah, 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 blah. So to provision like one server was like a 6-month or 6-week ordeal till everything came together. Now it's like I can launch, 1,000 instances in an hour with a credit card and a, iPad, which is crazy. So I think for when that ability to keep up with the velocity of cloud stuff, these tools are what's really, really interesting to me. And they, in my day, I feel old now, but yeah, whippersnappers back when I walked up both hill both ways to the data center, blah, blah, blah. But in those, when I was still doing a lot of operational stuff, the limiting factor, once we got all those servers, is if you're going to buy tools, it was really expensive, and they weren't exceptionally good at the time. Like, I remember monitoring tools were expensive, so we had Perl scripts that would ping all of our infrastructure, and then if it got a failure, it would parse that and send an email, and we had like these old compact all-in-one desktop PCs running Slackware that would run these cron tabs that would ping everything in. One day we got approved to get Netcool, which I was like, yes, this is awesome. And so we hooked it up and started adding in the IP address, and we're an internet service provider. So we had like tens of thousands of modem racks and servers and stuff to ping. And I remember the guy entering in like the first part of the spreadsheet that had all this stuff in. He's like, it won't take any more numbers. We're like, what do you mean it won't take any more numbers? Well, we got Netcool, but we only got licensed for 100 IP addresses, so because it blew our budget. So now, you know, I thought it was interesting to see Nagios sponsored here. Like, Nagios is not an overly complex monitoring system, but how many people here use Nagios? Like, yeah, everybody uses Nagios because it has utility. It's not that hard to administer, and it does what it needs to do availability checks. And there's a huge ecosystem of plugins, so you can figure out how to manage pretty much anything. That started it. I worked at a company. Anybody here use Xenos? So I was one of the early first 5 or 6 employees at Xenos, which is open source monitoring software a long time ago. And then you have OpenNMS and has a booth here, and there's a lot of free and open source software that's really pretty good for monitoring. It used to be a big cost and hard to manage. So anyhow, any other questions? Thanks for your time. I appreciate it.